Located on 85 acres and managed by the City of Santa Rosa's Utilities Department, the Laguna Treatment Plant services a wide geographical area with over 250,000 residents. Since its inception in 1968, our facility has increased the volume of wastewater it treats from 2 million gallons to currently around 18 million gallons daily. More than 500 miles of underground pipes bring wastewater to the plant, where water goes through 3 stages of treatment within a 24-hour period. The recycled water that leaves the Laguna plant is a high-quality, tertiary treated water that is safe for many reuse options. Welcome to the Laguna Treatment Plant. My name is Denise Cadman. I work as a natural resource specialist here with the City of Santa Rosa. I'll tell you a little bit more about my position as we go. But for now, let me tell you about what we do here at the treatment plant. Our job is to take a highly polluted source of water from the sewers and clean it up to a level where it can be safely returned to the environment. Now, this particular facility not only serves the City of Santa Rosa, but also a sub-regional area including Cotati, Rohnert Park, Sebastopol, unincorporated areas, and waste haulers. The cleaner the water comes in, the cleaner we can send it back out. So we have environmental compliance to make sure that especially our industrial dischargers don't put anything illegal into the sewer, things that would be difficult for us to clean. We also reach out to household dischargers. We have, for example, our pharmaceutical take-back program. We have made an agreement with local pharmacies to take back unused, unwanted, and expired medications that might otherwise be flushed down the drain. And since the program started 2 years ago, we've taken back over 8,000 pounds of pharmaceutical drugs that might otherwise be contaminating our water. Our flow here is somewhat of a moving target. Our dry season flow currently is about 14 million gallons of sewage a day coming into this facility, plus whatever stormwater leaks into our system. So ideally, no stormwater would come in, but as pipes get old and leak, when groundwater is saturated, we get infiltration and inflow into our system, which can bring our flow up much higher than 14 million gallons. So an annualized average for last year was just about 17 million gallons of water coming in via the sewers. That's 500 miles of underground pipe, and that's coming from households, 250,000 individuals, plus 6,000 business and industry that are discharging into the sanitary sewer. And our job then is to clean that water up and, following all our regulatory compliance, then return it to the environment. Our process involves 3 steps. Solids are removed in step 1, primary. And you see that there's still a lot of organic material in the water. It's quite cloudy and filled with suspended solids. This water goes on to step 2. That's secondary, and it's the real crucial step in our treatment process where we use living organisms to clean the water. So we have microscopic workforce of mostly bacteria, many different species, the same type of species playing the same ecological role they do out in nature. They're breaking down organic material, recycling it so that it can be used again. And in addition to the bacteria, we have other groups of organisms, including the members of the protist kingdom, like paramecium and amoeba and vorticella. And we also have microscopic animals here, such as this rotifer, which is a type of roundworm. So they're going to be eating up all the organic material that's making that water appear cloudy and removing it from the water. And when they're done, you can see a real transformation has occurred, that the water is now very clear. But it's not quite clear enough, so we're going to do a 3rd step of treatment called tertiary, where we trickle the water down through a 4-foot bed of anthracite coal. And those little spaces in between the bits of coal are going to trap the finest suspended solids as well as some potential pathogens. Now we have really crystal clear water, but it still may have microorganisms in it. And although most microorganisms are really our friendly neighborhood decomposers and recyclers, some do make us sick. So to make sure that no one gets sick from contact with the water, we use a disinfection system with ultraviolet light. UV light replaces the standard chlorine disinfection system seen in most sewage treatment plants and drinking water facilities. The light is powerful enough to literally rattle apart and unravel the DNA from organisms like bacteria and viruses that destroys them, so they're no longer a threat to human health. Now we've completed our cleaning process, but we have another huge job to do. We have to take this giant volume of water and return it safely to the hydrological cycle. It's important to know that all water on planet Earth is recycled water. There's no new water. In fact, you can safely say that the water you're drinking today is dinosaur pee. It's been around the hydrological block. It's been in the air, it's been in the ground, it's moved through living organisms countless times. So our job then is to safely return it to the environment, and eventually, of course, it'll be used again. The first step is storage. We have 1.6 billion gallons of storage capacity that allows us to store water for a period of time. Ultimately, though, that water, of course, has to be returned to the environment. Now, one option for us is discharge. So in the wintertime, we may discharge. We're legally allowed to discharge up to 5% of the volume of the Russian River. So all of our storage ponds are strategically located by natural waterways. This pond, Delta Pond, is located by the confluence of the Laguna de Santa Rosa and Santa Rosa Creek. So we have valves that can be opened up to release water from the pond, and that water then flows into the laguna and on to the Russian River and out to the Pacific Ocean. And meanwhile, of course, water is evaporating off the surface, it's transpiring out through the leaves of vegetation, and some may be infiltrating back into the groundwater system. During our discharge season, we're required for our permit to do a bioassay. This is a test conducted on a living organism. So we use rainbow trout, which you see in the aquarium here. We take really young fingerling trout. We put them in an aquarium filled with the water that's been cleaned up here and monitor their survival for over 4 days. We required a 90% survival to make our permit valid. And the trout, being sensitive to pollutants, are a good indicator species for us. So when they survive, which they always do, we can infer from that that any other fish or aquatic invertebrate living in the laguna or the creeks or the Russian River is going to be unharmed by our discharge. Now, discharge is not necessarily an option we use every year. So depending on the amount of flow to the treatment plant, how wet or dry our winter is basically, will dictate whether or not we discharge in a given year. What we prefer to do is save that water for a more valuable reuse option. Instead, we'd prefer to save all water possible for our summertime irrigation program. We have a recycled water program that delivers water that's been treated at this facility to over 6,000 acres of land for irrigation. About 80% of that land is farmland, which includes pasture at dairies, hay production, but you can grow anything you want. So we've got organic vegetables in our system, as well as lots of wine grapes. And then about 20% of that water is going for recreation and urban reuse. So we've got our parks, like Finley Park and a place to play. We've got the golf courses and the ball fields and the landscaping projects that also get irrigated with recycled water. This is really important because it does replace the need to use potable water on grass. So we wouldn't want to waste drinking water to irrigate a lawn, but we don't have to. We can still have that lawn green in our Mediterranean summer, and we can save our drinking water for drinking. So that's our summertime irrigation program, and what the city really wanted was something year-round that was not weather dependent. What we did was went to the geysers. Our geysers recharge project is currently our largest reuse option. We send the geysers an average of 14 million gallons a day. So we send them a little less in the summer because we're actively trying to save water for our farmers, and then more in the winter because we'd prefer to send it to the geysers than into our discharge program. The geysers are located up on the mountains in the Mayacamas, kind of straddling Lake and Sonoma County, largest geothermal operation in the world, but the geysers were running out of steam. So water is leaving the system faster than it can be replaced naturally by infiltration from rainfall. And the city of Santa Rosa now sends water to the geysers to inject into the steam fields where liquid hot rock comes up unusually close to the surface, turns it into steam, which can turn big turbines to generate a non-fossil fuel driven source of electricity. So we have a green electricity, and just the water we send them is good for an additional amount of electricity for about 85,000 homes. Large construction project to get that in place. 43-mile pipeline crosses the Santa Rosa Plain, climbs 1,800 vertical feet up the mountain ridge, and then injects 800 feet back down into the ground to reach those hot spots where steam can be produced. That's our treatment process. And before we go on, we're going to go into the lab. Lab is extremely important to what we do here because they're letting us know whether or not we're meeting all of our legal requirements. So we've got a full-scale lab that's going to test for a whole spectrum of constituents. And we'll take a look and tour the lab before we head on.
Hi, my name is Kathy. I'm a lab analyst here at the Laguna treatment plant. And this is our microbiology room. Here we test for the bacterial testing for the plant. One of the daily responsibilities for lab analysts is to collect a sample from the UV channels for bacteria testing. Here's our sample bottle. It's 100 mils, sterile. I go out to the channel and collect the sample and bring it back to the lab. Our main analysis performed here is a multiple tube fermentation method. Here we use lauryl sulfate broth, double strength, single strength, and a dilution. We inoculate the sample, or we inoculate the tubes with a sample at 10 mils, 1 mils, and a 0.1 dilution. We stick them in the incubator for 24 hours at 35 degrees plus or minus 0.5. After the 24 hours, we come over to the lamp and in each tube there's an inverted vial. We take a look to see if there's any gas forming or bubbles in the vial. We are testing for coliform bacteria. Coliform bacteria is an indicator bacteria for other pathogenic organisms that may be in the water. And they ferment lactose. This is why there would be a bubble in the sample. If the samples are negative, we stick them in the incubator for another 24 hours. And after that, if they are also negative, we can give them a less than result for MPN, which is our most probable number in determining a bacterial density. If a sample is positive, I would transfer from the double strength to BGB. BGB is brilliant green bile. It's a special media that's used just for detection of coliform bacteria. Coliforms are gram-negative bacteria, so BGB inhibits any positive gram bacteria and a couple other selective gram bacteria. This is also incubated for 24 hours at 35 degrees plus or minus 0.5. And after that, we see also if there is any gas forming bubbles. If it is positive, I call a senior operator and notify them, and they take the appropriate measures.
In addition to the testing we saw in the microbiology room, looking for microorganisms, we test for a whole spectrum of different potential contaminants. So here in the lab, these benches are set up for the testing of nutrients. So those are things like nitrogen and phosphorus. And in the corner, we're testing for solids. And the back wing of the lab is dedicated for the detection of metals and organics. Okay, now we're headed outside to tour through the treatment plant.